Good morning, seventh grade. Hope everyone's doing well. Um, Moving back into probability and to theoretical probability. So, we already discussed the basics of outcomes and to get the probability of various things that we're working on, and it can't be all real world situations. We did the dice, we're talking about Skittles, we're talking about Lego pieces. Again, endless possibilities. And, just like, think about, for those who like sports or watch sports, you want your team to win or you want to win or you want to be picked. It's all about like what's the probability that I may get picked first or last or in the middle, or this team might win or they may get knocked out first in like a tournament. All these different things that come into place. So I just want to show you guys another example based on this. So you can see here I have a magnetic board of just different letters and numbers here. So if I take the marker and look, right? So I know I have one. We're just going to count. So remember, the first thing we want to do is find the denominator. We want to find out what's the total amount we have, and then from there, then we can start thinking about the different outcomes and possibilities to get one of those to figure out our numerator. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so we have total 20 pieces. Okay, so 20 pieces here. And again, use your imagination. These can be anything you want. Okay, but we just have letters. Okay, so we're using the letters here, and we know we have, make this a little neater for you. We have 20 letters up here. All right. So from then, and there are a couple different things too. You got to think about if you mixed all these up. So obviously you can see they're all mixed between, you got green, purples, yellows, orange, pinks, right? So from there, if you look at the magnets on the board, if I want to think about if I took all these and placed them in the bag, but before I do that, I need to know specifically how many of each color I have, which is going to help me figure out with the numerator. So let's start with the yellows, okay? So we're going to do we'll do yellow up here. Yellow is, we got 1, 2, 3, 4, 5, 6 yellow. Next color we have is green. So we got 1, 2, 3 green. Next color is purple. We got 1, 2, 3, 4 purple. Then we got pink. So we'll do purple here. We'll do PI for pink. And we got 1, 2, 3 pinks. And then the last color we have is the orange. And we got 1, 2, 3, 4 orange. Okay? So just to make sure, right? We got all our numbers here. We have everything we have here. So when we're understanding, defining the probability and the outcomes, we know we have total of 20. So if I took all these now I know I have my numbers. So we took them all, we dumped them out. I could just put them all down here so we couldn't see, right? Put them down here, put them together, mix them up. Okay, so if you want to say, if I'm going to reach in here and I'm going to close my eyes, I wanted to, you use your imagination as you're looking at the video. What's the probability of me reaching down and grabbing a purple magnet, right? So think about it. Okay, the visualizations are the best part because then you can truly see. Now, if it was in a bag, it's still the same process. You just have to think about what's in there as you're doing it. Just like, anything you're doing about pieces and stuff, you need to know how many you have prior to finding the possible outcomes. So if I know that I have 4 purple, same thing. Let me double check. I'm bringing it up for you. I got 1 purple, 2, 3, 4. So I know that the 4 purple is going to be my what? My numerator. So I could bring it over. You could say I got 1, 2, 3, 4 total purples that I can possibly grab out of this whole batch of magnetic letters and numbers of 20. So if I'm looking at that, okay, so I have a chance of getting 4 out of the 20 if I reach in, right? So from there, then remember what we spoke about is getting the actual reduced fraction from what you're getting. Some of them you can't. Some of them that's the way it is because when you're going to have to convert these into percent, you have to try to get into simplest form first, right? Reduce. So if I look at the 4 and 20, let me just bring this up over here for you. I know that between the 4 and 20, we can definitely reduce, right? If we did the factors of 4 and 20 and the we know that they are both composites, so they're both going to work where we can use. So what number can go into 4 and 20? Okay, and you should be thinking about this, that some people may say, oh, it's 5, because 4 times 5 gives you 20, which is correct, but again, can 5 go into 4? It cannot. So you have to think about what number can go into the numerator and the denominator that is the same number. So in this case, it would be 4 and 4, right? 4 goes into itself 1 time, and 4 goes into 20 5 times. Now you have what you need. We know that 1/5 is reduced to the lowest terms from 420. So we reached into the bag of letters and numbers. We wanted to get a purple. We know that we have 4 out of a 20 probability chance to get it, and then we reduce to 1/5 based on 4 goes into both the numerator and denominator. Okay? So let's put these lovely magnets back here in the bag. Get rid of this. Okay? So same thing now. Let's do, just like what's the probability of, let's say, getting a green. Put that in parentheses so you could differentiate the two. And let's do green and what other color we want to do? Let's do orange. Okay? Orange. So we know based on here, we should have how many green? We should have 3 green, right? So we got 1, 2, 3 green. Okay? Then we know orange, we should have at least 4. So 1, 2, 3, 4. Perfect. Okay? And these stay here. So once you do that, then you look, again, out of the total bag of numbers and letters, we know that there is what again? The denominator should be 20. Perfect. Okay, so that's I'm reaching in. I want to reach in, close my eyes, and I want to see if I can take one of these. What's the probability that I would get a green or an orange? And this is where we go back now to figure out the numerator. So we have 3 green, and we have 4 orange. So again, just very easy. You're adding up the 2 together. So 1, 2, 3, 4, 5, 6, 7. So again, if I reach down here, and these are all here mixed up together, and these are in a bag or just here, and my eyes are closed, I know that and say, what's the probability of me grabbing a green and or a orange? I know I'm going to go down like this, okay, and the chances are it's going to be a 7 out of 20. So that's the probability because I'm combining the two. Then you think about it, okay, so between 7 and 20, can I then reduce these two numbers? Now we know that 20 is a composite number, 1, 20, 5, 4, 10, 2. Multiple factors that go into 20. However, with 7, you only have 1 and 7. So in this case, 7/20 remains the same. You cannot reduce these two sets. Okay? That has to stay the same of 7/20. Okay? And we'll do one last one. What would be the probability now if I wanted to get and reach in and get a, let's do yellow, let's do green, and let's do pink. So we know, again, what's the total? We have 20 total letters and numbers. So we want to get how many yellow? So we have 1, 2, 3, 4, 5, 6. So we got 6 yellow. And, we said green, right? We have 3. Make sure we have 3 in the bag. We got 3. Oops, sorry, guys. Plus the 3. And then we want to get the pink. We should have 3 pink, which we do. 1, 2, 3 pink. So again, you want to figure out what would be the condition of me going in and getting a yellow, green, or pink letter or number magnet to be my numerator. So we have 6, 7, 8, 9, 10, 11, 12, right? So if we take those and think about it, we have 12 over 20. So that's the numerator and the denominator that we could possibly get the outcomes in if we wanted to choose a yellow, a green, or a pink. Okay? Awesome. Again, from there, then you think about it. Think about the 12 and the 20, right? Both these numbers are composite numbers. You think about the 12. You got 1, 2, 3, 4, 6, 12, right? 20, we just did before. 10, 2, 1, 20, there's 5, 4. So, but you think about that, when you have to convert and make it reduce to lowest terms, remember, it has to be the same number that you're using for the numerator and denominator. So what number do you guys want to use? Okay, think about it in your mind. Some of you may say, no, we can use that one. Again, there's different numbers you can use. The steps may go a little bit quicker depending on what number you use. So if we did 12 and 20, some people are like, oh, I know 12. However, can 12 go into 20? It cannot go into 20. So you cannot use 12. What about, you want to use 2? Let's try 2. Okay? How many times can 2 go into 12? We know that it goes 6 times, right? How many times can 2 go into 20? We know that it's 10 times. Okay, so you got 6/10, which is fine. Now you're slowly going down to reduce the lowest terms. But now you look at the 6 and 10. Composite number, right? The factors of 6 are 1, 2, 3, 6. And we got 10 is 1, 2, 5, 10. We could still break it down. So what number would you want to use that goes into 6 and 10? Remember, it has to be the same number. You're not using the number 1. We know that, yeah, some people like 3. But again, if you do 3, 3 absolutely does go into 6. But 3 cannot go into 10. So you got to think what number can go into the numerator and the denominator to make the statement true. So it should be 2 and 2. 2 can go into 6 3 times, and 2 can go into 10 5 times. Now you have your both set. 3 is prime, 5 is prime. So again, you're thinking about working backwards, retracing your steps, thinking about the probability. And in this case, with the probability, is we're working with the magnets, okay? And you're thinking about the different outcomes. So I really want you guys, your assignment is to really think about, find something in your house that you have that you can take account of something. Or, again, it has to be like different colors. You don't want to take a bag of chips because the bag of chips obviously is the same chip, maybe different pieces of it, but it's the same chip. You want to think about something that has multiple flavors or different colors and stuff like that. And if you don't have that, you could take markers, you could take crayons. Like I said, there are endless possibilities you can use. But when we come back and we meet for our Zoom later in the week, I want you guys to think about it and then be able to share out. Maybe record what you did and then write down and show, and then you can even email that and we can bring that up to see how you guys worked out the probability of getting something. Or we can work on the next time when we do the live lesson that we can use my board and you guys can show me what you're doing. Or again, we can use the whiteboard app and you guys can flip it around and show me what you did. So think about that with all relation to probability. You want to think about what's the quickest outcome I can get to get what I want based on if it's in numbers, if it's a team, if it's candy, if it's people. So many things you can use. Okay, so continue to use the resources and methods that are breaking down to find the understanding, and then keep using the textbook as well, because those really give you great guided and independent practices. And then the main part is what we're going to get into is when you're taking the open-ended and word form of all these different components and you're putting into a higher order thinking question. Then you have to break it down between the numbers, and that's where you're really pulling out. So we'll get back to that later in the week as well. But keep working hard, keep using the probability, keep thinking about the vocabulary that we're using from outcomes, condition, theoretical, the probability. We got numerator, we got denominator, we have factors, multiples. So many things come into place with probability. So I really want you to have fun with it and think about when we meet next time how you can show me the different scenarios and examples that you did, or even if you're outside, think about something, you have on your porch or in the street, rocks, there's so many different things you can look at to see about it. If you were going to grab something from the ground based on where you are that you could pick out. So again, just think about that stuff, and we'll get back later in the week, and we'll touch base more on Module 12. Okay? Everybody have a great rest of the day, and I will see you soon.